the episode number 2 of the trapezium rule. I believe by now you have watched the episode 1 and gotten all the facts you need to be able to arm yourself against any question on trapezium rule. Come, let's attack this one with that armor that you have. Use the trapezium rule with the ordinates at x equals to 1, 2, 3, 4, and 5 to calculate correct to 2 decimal places an approximate value of integral from 1 to 5, the square root of 2x plus the 8 divided by x squared dx. So this is not direct integration. Then in doing so, we have to also construct a table for the values of x and the values of the integral. So let's put that into practice. So now when we draw the table, we have the values of x ranging from 1, 2, 3, 4. This is showing the ordinate. So this is the ordinate we have. Here we can put everything in our calculator. The square root of 2x plus 8, we convert this become a power of negative. So you'll only be changing the value of x with these numbers. So when you put 1 in place of x here, you will be having 3.162. That is the first one. Then in the second one, that will be 2.449. The third one will be 2.625. Yeah, 625. Then for the fourth one, you will be having 2.915. Then the final one, you have 3.212. All right. So this is what we are going to have. Now you will ask the question whether we already know what the height will be, because we have been given this interval already. So we are aware that the height is interval of 1, 1, 1. But you can also try and see if you will get the same. So that could have been the first thing we will find, as in age. Let me use different color. This will have been age equals to the upper limit 5, lower limit 1. Here we have not been given the sub-interval. Remember our first episode. The sub-interval is a number of trapezium we have. But here we're given the ordinate, which is the interval itself. So it will be the interval. How many are they? 1, 2, 3, 4, 5. So 5 minus what? 1. 5 minus 1. You can see the top will be 4, the down will be 4. So it will be 1. So we are adding 1 to the lower limit. 1 plus this, plus this, plus this. How can we get to that? That is why I have not calculated for this. But that's what will be the first thing you do anyway. So now that we have this, remember the formula we have? Area equals to half the age, y naught plus yn plus 2 y1 y2. Let's just end it at yn minus 1, so that you have a lot of space in there. You remember we said that word, half the height times the first and last, that's the sum of the first and last, then plus twice all other terms. So in this case, I'll be having 1/2 times 1, then multiplying the first one, that will be 3.162 plus the last one, 3.212 in a bracket, plus twice the remaining ones. How many are they? 3 of them. So 2.449 plus 2.625 plus 2.915. So this is what we are having. So if you multiply half by 1, you still get half. So let's get the first answer here. So if you add these two numbers there, you'll be having 6.374 plus twice 1, 2, 3. When we add that, that will give us 7.986. We enclose that. So we can compute all of them or multiply this first. So 1/2 times the summation of all of this. And that will be 22.352. So when you multiply that by 0.5, that will be giving you 11.176. But don't forget, the question gives you the number of decimal places. We are giving what? 2 decimal places. So now what will it be? 1, 2. So area will be equals to 11.18 square unit. So now with what we did in the first episode, with what we are having now, you should be able to connect the dots. How we can use the trapezoidal rule in evaluating the approximate values of integral function or a function under integration. So you just need to know your age, know the interval, then you put the function, replacing the x by each interval. Then the formula, you put it in there, you come back to the same place. If you have a question, leave that in the comment section. Let's get interactive because we are learning together. Share, comment, and subscribe.